everybody, and hi from my shop. I'm going to be doing another test on this car radio that I've been working on. Last round of testing strongly suggested that there's nothing wrong with the radio. Now, the radio's here on my bench. It's not in the car, obviously, so perhaps the circumstances here on my bench are somewhat different than in the automobile. For instance, an obvious one is the antenna that I have connected here is done a little differently than pushing an antenna connector into the slot here. So as a small example. So another thing that's different about my bench here, and this is particularly true because it's winter in Canada, is that it's really quite cold on my bench. Let's just see how cold it really is. Okay, so this radio and my bench top is reading 16 degrees C. 16 is pretty chilly. It's not freezing by any means, but far from being hot. Hot would be 30 degrees C, so it's far from that. So we've been operating this radio essentially in a refrigerator, and most of the time radios in cars take quite a bit of heat. Not sometimes from the heating system of the car, and most often just from the heat of the sun, particularly in the summer, or if you're in a sunny, warm location, then rolled up window is going to heat that radio up to a very high degree, high temperature rather, and then you're going to get in your car, turn it on, and not think twice about it. So these radios often run very, very hot, or in hot circumstances, let's put it that way. So that's what I'm going to try to imitate here today. Now, so I've got to turn this whole thing back on. And before I do that, I need to double check a few things. So first we're going to put the output down on my DC power supply, and just in case I bumped the control and didn't know it. Wouldn't want to turn it on and find out it's set to 30 volts or something like that. And let's see, speaker still connected, volt meter, which I got to turn on, my output meter still connected. I mean, everything should be ready to go. I should just be able to throw the switch, but I do like to look things over a little bit because stuff happens, and you never know when Draper was in here working. He could have been in here working on his own. But everything looks fine. So we're going to switch on here and raise the voltage up to 12. I'm watching the current. Okay, we're up around 12 volts now. The current flow from the power supply is the same as it was yesterday. And there's the radio. Oh, by the way, I'm using a different microphone. I meant to say that right from the start. I've been experimenting with microphones. I have a few of them here, and I have a couple that are very promising high-fidelity microphones, but the output is low on them. Now this one I'm using is not a particularly high-fidelity microphone, but I think the output is relatively okay. So please, if you would, comment on the video about the volume you're hearing. When my test videos suggested it's a little low, but I don't know that it's so low that it's bad. So maybe you'll get a better impression, compared to other videos and in your own circumstances there, just whether the video here is working well or not, or the sound rather. So, and the reason I'm doing this is I'm looking for a better microphone. I'm trying to get away from this compression sound that exhibits that comes with the built-in microphone on my camera, and I'm hoping the sound here will be a little better. I'm not sure if that's the case. So anyway, radio's operating. Let's get our signal going here. That's our 100 megacycle signal. I'm pretty sure I've tuned this radio off, so I'll have to hunt it down again. So let's hook the radio back up to the signal generator. And actually, you know what? It doesn't have to be on the signal generator. I'm just transmitting into the into my shop, the FM signal. Let's see if we can find it now. Should find a tone. Okay. Now, by the way, when you're watching YouTube videos, and my videos anyway, and we're dealing with sound level issues, one of the things that happens is there's a fair bit of compression that takes place, or automatic volume control that takes place either here in my own setup, my own camera, or in the YouTube processor, or somewhere along the line there's a fair bit of automatic volume control activity. So you can easily be fooled watching a YouTube video while I'm fiddling around with small changes in volume at this end. So just to let you know, I think the last video, there's a very clear point where I turn on the radio, the tone comes on, it's fairly loud and quickly decreases, and then I'm talking about this radio fading out. Well, that decrease is not the radio fading out. That's just the automatic volume control in the YouTube audio system. So, this all looks pretty good. Let me get it's the same output, in this case 4.2. It's right around the same output as yesterday. Maybe if I just tune this a little bit, I can get it to go up a bit here. Wow. Well. Of course, when it gets this sound, my meter jumps way up, but it's distorted a bit. So, great. So that's good. That's just below 5 on the meter. This is one of the antenna lines, by the way, or antenna lines. One of my microphone wires, which is hanging all over here. So, well, I think it's time to heat this guy up. That's what we're going to do. We're doing a heat run test. Let's cook them. Okay, now I've got quite the heat gun here. This is not a mild heat gun. This is a pretty monstrous guy here. Heat and strip, electric paint remover. So this is not the right kind of heat gun to have in a shop like this. I don't plan to peel any paint off of this radio. But this is what I've got. So unfortunately, or fortunately, this won't take long. Let's put it that way. Better plug this in. I don't want to knock down my camera with all these cords here and various things. Now my camera, my Logitech camera, comes with some noise reduction capabilities, and it certainly operates with the microphone that's built into the camera. For instance, you never hear the hiss of my computer fans. It works pretty cool, but I think that's where the compression sound comes from. I'm not sure. So when I turn this baby on, there may not be any more of that processing because I'm using an external microphone. So hold your ears. And you know what I'm going to do? Because you don't really want to watch me blow hot air, I'm going to put the camera where you can see the signal strength meter. Give me a second there. And you can watch the meter as I heat this thing up. When you get up close to it, I think the bright light will go away. Okay, it's not quite in focus. That's not bad, eh? That's pretty good. Now, if you see the meter, I stand still, everything's still, the meter is still. If I just move, this is my microphone wire, it's just hanging in the shop. Well, what's happening is, because the radio is receiving this FM signal from my little transmitter, I'm actually affecting the radio waves in the shop when I move around in that. So you see a little bouncing around of the control there. It's just me moving around, but I'll try my best not to be moving around. Now let's put it right on 4 here. I'll turn it up a bit. Get it right on 4. Hey, that's right on 4, isn't it? Yeah, that's good. Now I'm going to start by trying to heat up areas of the radio first. The problem is I can't cool them down after very rapidly. So you're not going to see what it is I'm heating unless we see an effect. We're all ready here. Hopefully I don't blow a fuse when I turn this thing on too. Here we go. Okay, I've started now. Oh my gosh. Wow, that's quite an effect there. Okay. I know what to think of that. Wow, I was not expecting that at all. Now look at the reading. Okay, so my radio is now 36 degrees, 37 degrees, 28, 45, 50. Wow, I really heated this guy up a little bit, didn't I? This part of the radio is still pretty cool, around 20, 25, but this part up here is really quite warm now. Oh yeah, I can feel it with my hand. I really, yeah. That doesn't smell so good either, but I think that's the actual heat gun I'm smelling. Okay, so what did we find out there? Oh my gosh, look at that. Now, all kinds of things could have happened there. The first one is the radio may have just tuned. So let's tune it right away and see if we can bring it back by tuning. Here we go. Try now. I can't hear anything here. Okay, forget the meter. Meter's all off scale here. I can't receive the signal anymore. There it is. Okay, I don't know what to do now. There's the signal. I don't know what to think of that test. Wow, that had a dramatic effect, but I don't know what to think of it. The heat blast is pretty general here. You know, I'm going to have to try to set this up again. So we can see this. Maybe I'll use a different meter and a different camera angle. You can watch what I'm doing with the blower. And man, that made a huge difference in the signal. Yeah, that's me moving around now. You see the signal going up and down. So not the best thing having this signal fed through the air, but wonder if I can change that a little bit. Make a better arrangement here. Let's try something. Let's try a little something here. Wow, okay. Oh my gosh. Well, that's my hand going on and off the antenna wire. It's really, really sensitive here. Let me stop for a second. Okay, so a little bit of time has gone by, and the radio is cooled down to 19 and 20 degrees. It's probably not going to go back down to 16, even though my top of my bench is 16. Now, here's a few things. You see how the meter's moving around there? That's from me moving around, just moving around in my chair. Look at that. I come over here, I can knock the signal right out. So, guess what? If I pick up the heat gun and without turning it on, just wave it around, that's not doing too much, is it? No, that's not doing too much. In fact, it got a little better. Yeah. All I'm trying to show you is that there, I'm putting the heat gun down over here. You know, FM signals, high frequency signals, they do lots of funny things in small spaces. So that's me moving around again. So got to keep that in mind when I'm doing this test. Now, I think it's come back up the way it was. I'm not convinced that heating it up just didn't detune it. Not convinced at all. And when I heat this up, there's quite a blast coming out of that heat gun. It's heating up the whole radio a lot, rapidly, a large area of it anyway. But what I have is I have the ability to cool it down more selectively, because I have a air pump that will pump that cool air, probably that same 16 degree C air, out of it. And it's a very small nozzle. I can be very specific with it. So I'm going to try to heat the radio up again, see the signal fall off, and then use my air pump to try to be more specific about where this effect is taking place. Another thing I'm going to do, as soon as I heat it up and it goes off, I'm going to retune the radio and see if it just doesn't tune right back in somewhere else. So, okay, here we go on the heat. And the reading is both, I'll try not to move much while I'm doing this. Okay, I'll hold the heat gun right about here. I'm going to wave it around or anything. Here we go. Okay, I did move it around a bit. I did find an area that seemed to be more sensitive. Now, let me try retuning the radio and we'll see what happens here. Okay, now I've made a mess of it because, oh wait a minute, I can't tune it like that. So now I've made a mess of it because I've retuned it. I don't know where the signal is. Doggone it. Let's turn it up. Not much coming in at all. There it is. Okay, there it is, and look, it's slowly coming up. So I'm going to put on my air pump and start cooling it off selectively. Right? Okay, so my air pump is not as specific as I had hoped. It's also putting out a pretty wide blast of air. Now, I turned up the volume a bit, and you can see what's happened. Let's check the temperature on the radio now. 22, 21, 25, 24. The area that seemed to be most sensitive is the IF strip area. Now, because of all this hand movement and stuff, look at that, eh? It's just about impossible for me to read the meter and interpret the results as my hand is waving all over the place here. Let's try a different camera shot. Yeah, I think I'll stop and start it up again on a different camera. Okay, well I did a lot of fooling around to try to get another meter so it could be seen on camera what's happening. But unfortunately, the only meter that's really sensitive and appropriate for this work is the output meter. I do have another one, but I just don't want to drag it out. It's got its own problems anyway. So I tried my digital meters. I tried this guy. He's not going upscale high enough to get a good visual reading. So unfortunately, you're just going to have to try to keep your eye on this thing, which I know you cannot. I'm pretty sure you cannot see. But right now it's around 5.5, 6.5 if I put my arm down. Oh boy. Okay, so what are we going to try to do now? Anytime I move my hand around this thing, it acts up, of course. Let's repeat the heat up, cool down thing, and see if we can get a little more precise on where things are happening here. As I said, I'm still unconvinced that I'm not just tuning the radio out. Now, it looks like blowing around this area has a very immediate effect. Blowing around here seems to have some effect. Blowing on the back part here doesn't seem to have any effect. So let's start back here and see if we can eliminate something. There we go. Once again, I'll try not to move, so the meter reading is, if it's changing, it's only because of temperature. Right. Okay, so the meter's reading 6 over here right now. Here we go. Okay, there was no change from that heating, and that warmed it up a little bit, not much. Not much. 24, 23. Not too much. Let's give it a little more. Okay, so it's reading around 8. Okay, I got a dramatic drop off. But I believe a fair bit of the heat is blasting. It's blasting back this way. So I remain suspicious that the heat-sensitive area is here, not this piece in the back. But now it's all heated up. It's gone quiet again. Let's try cooling it down. I think I see what it might be here. I think I see what it might be. And I shall show you what I think is going on here. In this very crude way of heating and cooling things up and down. Okay, using my very close magnifier. See those two guys there? It certainly seemed I apply heat to those and cooling, and you get a rapid change in the operation of the radio. And no surprise in that at all. You change the value of these capacitors and the radio detunes. Now, I don't know what these are exactly. Gotta assume they have something to do with the FM though. And it was pretty clear. See, there's not a lot of other parts right around here. Well, you know, it's a car radio, so there's parts around everything. I think that's all that's happening. Is I'm just heating up those capacitors and detuning the radio, and I don't think I'm succeeding in anything with this particular technique. And I really don't know how to heat up individual components. I don't have the capability of doing that. At least I've never. Let me turn this down. This is kind of driving me nuts here. That tone. Well, What to do, what to do. We still have that grounding deal where I got these things grounded with clip leads, and that's not very good either. So there's signal variations going on there. Yeah. I think we ought to reassemble the radio at this point and see what it does. Yeah, I think that's what has to happen. Well, I'm going to post these videos. I've got other things to do today. I'll give all of you a chance to watch these and comment again on this radio. I did speak to the owner, by the way. I should tell you this. Spoke to the owner, described the situation. He said mostly he likes listening to the sound of the engine anyway, but he would like this radio to play properly, although he said he mostly listens to the engine. So I think, he understands that the problem may not be in the radio, it may be outside of the radio. So other than removing all the particles that were in here, or most of the particles that were in here, I really haven't done anything to it. Now the challenge is to get it reassembled with it still working properly. That should be interesting too. So anyway, that's where it stands now, and looking forward to your comments. Okay, so Steve, the Time Spiders, has reminded me to check the antenna jack a little more closely, because I had noticed earlier it was corroded. So let's take a good close look at that antenna jack. I'm still using the alternate microphone, by the way, so if you're finding the audio too low, please let me know. I'll just go back to the regular mic here for now. So here's the jack. You see, what I'm thinking is there's enough corrosion products right in here to short the lead to here. Now that's probably not really the problem, if there is a problem. The fact that you see corrosion here tells you what's going on inside this connector. It looks like this. And so, maybe we can even see right inside the opening there. Nothing too impressive about that, is it? Yeah, that's really terrible, in fact, isn't it? So, let's see what we can do about that. I mean, even if it's not the cause, it could be the cause of something that we would rather not have. Now, just come on, camera, stop fighting with me. You're fighting. Now, you see, when I use an external camera, external microphone, you don't get all that horrible microphone noise as I drop the camera and all that kind of stuff happens here. Sit there, will ya? You're worse than a cat, for crying out loud. Okay. Now, what kind of dumb things can we do? Let's turn off the radio first, because I'm tired of listening to the tone. Turn off a few other things here. And let's do something crazy. We'll measure the resistance across that connector. That sounds crazy. Let's do it. Okay, we would certainly expect open circuit. Here we go. Now the outside of this has been soldered right onto the frame, so there's no question about that connection. Oh my gosh. What's going on there? Oh my gosh. You know what? I just saw a dead short in that connector. I got to get the meter up here where you can see it, because I can't believe it. Okay, not the best angle on the meter, but you can see it anyway. Oh, now you can't. Come on. Try and cooperate with me. There we go. Okay, so I short the leads on the meter. You see it drop to 0. Okay, there's only 3 digits on the meter. You're seeing them all. So here we go. Let's try this again. Go here. And here. Oh my gosh, it's a 0. Am I doing something stupid here? would that be a 0? I'm stunned. Okay, I'm way up on the 200 meg ohm. Let's bring it down to 20K now. Maybe we'll see a resistance this way. 0. Is that normal? You know, 0 for my DC meter, but not 0 because there's a coil there for the incoming signal. Maybe this is a dumb way of testing this. Wow. Let's go right down. 200 ohms now. So there I'm reading 3.8. Pretty 3.8. Well, okay, if that's a coil resistance that I'm reading, and it could easily be, then what I should do is clean this connector and then check it again and see if it's exactly the same. Let's get a good solid reading here. So let's get a good solid reading here. .8 ohms. 3.8 ohms. 3.8 ohms. I should write that down, shouldn't I? Because the next thing you know, it'll be 8.3 ohms. 3.8 ohms. Just writing it down here. 3.8. 3.8. Any of you watched Jimmy Kimmel last night? You would have seen our illustrious Mayor of Toronto on Jimmy Kimmel last night. I think most of Canada was watching. Most of Toronto was certainly watching. I'm not even going to comment because I am so beyond when it comes to the Mayor of Toronto. I just don't know what to say anymore other than, look, I was a public employee and I did my duty. That's all I'm going to say. You can hear the anger in my voice. I'm very angry about the whole situation. So anyway, moving on here. Next thing you know, I'll be too upset to do the work. So let's clean this up somehow. How am I going to clean that up? What have I got that would clean that? Yeah, I just can't imagine you get a, well, I won't say that. I was going to say a dead short, but it's not a dead short, is it? I'm pretty sure I'm just measuring a coil in there. But we'll fiddle around here and see if we make any difference. I suppose there's a similar problem inside the connector at the bottom with some corrosion. Now, how did this ever get corroded here anyway? You know, sometimes water can make it in to things through the antenna line. Now you'd have to imagine water somehow getting into the antenna cable and traveling all the way through the car to the radio. A little bit far-fetched to think that that could happen. But, you know, over a long, long period of time, things happen. Pretty sure I've got a antenna connector here, a car antenna connector handy. There it is right here. Let's put it in there. Nice new shiny one. I don't know why we put it in there. Really makes a very good connection. Doesn't want to come out after. Now, can we see way up inside here or not? Let's give it a shot here. Oh, look at it up in there. It's not looking too good, is it? See if I can shine this light right in it. Wow. Well, you know, is that a short circuit happening up there? Or is that just a little bit of non-conductive debris and dirt and stuff like that? You know, a lot of corrosion products are not conductive. Rust is moderately conductive. Copper oxide is very conductive. These super thin films that occur on all shiny metals like nickel, stainless steel, things like that, those are all conductive because they're so thin that the electron cloud can still penetrate. They don't lock the electron cloud in. So what are we going to do here in there? What have I got that I can shove in there? And like a pipe cleaner would be a great thing. A pipe cleaner. Oh boy, I haven't seen a pipe cleaner in here for quite a while. Yeah, I'm not sure I got anything I can shove up there that's going to clean it. On the other hand, that's how to do it. Okay, what do you think that did? Think that did anything at all? Let's take a look. See what we can see up here. Hold on, let me get my flashlight. Well, it didn't look like it did much. In there, I mean, if there's anything loose, it's looser now. So let me give it a little blow. Whoops. Here. Okay, try not to fall. Okay, stand still now. Don't fall. See the blast coming out of the back of that? I don't know if that was visible on camera, but on my eye there was a blast of dust that came out of the back of that. Now, question is, has this affected the resistance at all? The resistance was 3.8 ohms. Let's see if it still says 3.8 ohms. 3.8 ohms. So I don't think there's any doubt. I'm just reading a coil resistance just inside there. We're not going to dwell on that any longer. And that would appear to be it. Once again, I don't know what else to do, so I'm going to post this video along with the others and see what more comments I get.